Welcome to solverfy.
Okay, so we have the following molecule. Oh, I could do slightly better than that. And we've got a chlorine here and a chlorine here. And the question is, among the molecules shown, 1, 2, 3, or 4, shown below, which of these is the meso isomer of this structure? Now, one important thing to recognize about meso compounds when you have exactly two stereocenters is that they can never be SS and they can never be RR. They must be SR. And when they are SR, they are also RS, right? Because their enantiomers are superimposable and therefore identical, right? So all you need to do to determine whether something is when it has exactly two stereocenters, whether it is meso or not, if it contains a mirror plane of symmetry, you're sure for other reasons that it is meso, is determine whether or not it is SS or RR or perhaps SR or RS, which would indicate meso. Okay, so one shortcut you could take with a question like this is to simply guess. Let's make this a wedge. Let's make this a hash. Okay. So this is looking like option 1 or 2. And then we can say, well, what if this was a dash, which would mean there's a hydrogen here on a wedge. Is this SR or RS? And from here, it's simply a matter of assigning priority to the groups, right? Chlorine is going to be the highest. Carbon attached to chlorine is second highest. This carbon attached to carbon is third. And our lowest priority group, hydrogen, is in the back. Okay. If we go from 1 to 2 to 3, we see that this is clockwise. And when the lowest priority substituent is in the back and we go clockwise, we know that our stereocenter is R. Okay, we'll repeat the process for the second stereocenter. Note now that our lowest priority substituent, hydrogen, is not in the back, right? Which means if it looks like R, it means it's S, and if it looks like S, it means it's R. Still, chlorine is the highest. Carbon attached to chlorine is the third highest. This carbon is the third highest, and the hydrogen is the lowest priority. If we connect 1 to 2 to 3, it is clockwise, which would be R, except for our lowest priority substituent is not in the back, which means we get S. Okay. And so I can put an S here. Great. So this tells us that option 1, gives us R and S. And if it's otherwise symmetric, which it is, right, then this must be the meso isomer, right? So it is number 1, or the one that looks in their drawing like so. There you go.